Hello, my name is Christopher DeLay. I'm here again to talk to you about PKI. So I'm basically doing this series. It's kind of like an introduction to PKI series, just really starting out at a very high level and just talking about, the technologies from a basic standpoint. And, if there's enough interest in this series, I get feedback that is positive, and I also, definitely have a fair amount of people view these. I'll keep going and eventually get into more detail, but my goal right now is just to provide an introduction if people are not familiar with certificates or PKI, and provide explanations of basically how the things work from a high level view, and then hopefully over time be able to drill down on those topics and get into more specific details and the technology and all how everything works in detail. So today we're just going to be talking about certificates, and again, this is kind of high level, so we're not going to get into extreme specifics. Basically, we're just going to talk about what a certificate is, and we're basically just going to look at a certificate and see what the contents of a certificate is, and what those what those different fields in a certificate are used for. So a certificate is a digital document that binds an identity to a public key. Excuse me. So the key things here obviously are identity and a public key. And so the identity could be the name of a user, it could be a name of a service, it could be name of a computer. And we'll see there's different fields where that identity information can be stored. And the public key is the key that's embedded in the certificate. Now, of course, with the public key, there's also a private key. The private key is not stored in the certificate. It can be stored in several different places. For a Windows machine, it's usually stored on the machine and protected by DPAPI, which is the Data Protection API. So these are the two components of a certificate. This allows you to be able to validate the identity of a user or service or computer, and the key can also be used for certain cryptographic functions as well. Whereas if you just had if you had a key pair without it being bound to an identity, you could still do cryptographic functions, but you wouldn't necessarily be able to tie those to a specific user or computer or service. So this gives you some obviously additional functionality over just having a key pair. So we're going to look at a certificate and look at the various fields and talk about what those various fields are used for. So here I have a certificate. This is just one I just downloaded from the www.microsoft.com website to just use this as an example. So here we see the certificate as it's viewed through the Windows graphical user interface, or GUI. So when we first open the certificate, we come to this general field with general tab, which is just going to give us very kind of like an overview of the certificate. And so we see this certificate can be used for these two things. So basically it can be used to prove your identity to a remote computer or ensures identity to a remote computer. And we'll see a little bit more of what those are. These last two are referring to, these are referring to the CPS, or certificate policy statement. So you'll see there's an issuer statement that you can click on here, and that'll bring up the CPS for this PKI. So a certificate practice statement basically just discusses the whole way the entire PKI is operated, and even includes how the servers are stored, how the cooling is handled in the data center, how the CAs are secured, pretty much everything about the environment. And the purpose of the CPS is if you want to use a certificate provider, either to issue you certificates, or if you're deciding to trust certificates issued by that provider, you can read their CPS and determine whether you think they do a good enough job from a management and security standpoint to actually trust those certificates, or of course you could choose not to if you don't feel that their controls are adequate. We see that this is the identity in the certificate is www.microsoft.com, and then we also next see the CA that issued this certificate, which is Microsoft RSA TLS CA01. And then finally we see the validity period. So this is obviously valid from August 28th, 2020 to August 28th, 2021. So the certificate's valid for a period of 1 year. there's the issuer statement. You can click on this and this will bring up a web page that has the CPS. Next, we're going to look at the certification path. So here we see the entire chain of the certificate. So there's this Microsoft.com certificate. It chains up to this issuing CA, which is called Microsoft RSA TLS CA01. And then that chains up to this DigiCert Baltimore root. And that would be the trust anchor of the entire PKI here. So in order to trust this PKI, I would have to have that DigiCert certificate installed in my trusted root store. Finally, we're going to go ahead and take a look at the details. So this is going to show us the specific fields. So the specific fields you'll see in here there are version 1 fields. So you can even kind of just look at them by version 1 fields. And then there are the extensions. So the version 1 fields were defined in the first version of the X.509 standard. These are additional fields that allow the certificate to be validated and used for different purposes. And it was found at some point that those were not adequate, so they added this idea of extensions. So the thing with extensions is unlike version 1 fields, which are sort of required, the extensions are not required. So you don't have to put any of these extensions in your certificate if you don't want to. However, they do provide a bit additional functionality a lot of times that you would want to have. And there are certain extensions that are in the RFC, so there are certain ones that should be understood by any like PKI enabled application or service. But you can create your own extensions if you want to. So if you wanted to create your own custom extension to work with your application, you could certainly do that. The limitation of that, though, is most applications are only going to understand extensions that are defined in the RFC. So an example of, so we have the certificate information one as an example. So this is not one that's defined in the RFC. This is like a Microsoft specific extension. And so we would certainly, most likely expect Microsoft applications to understand this, but outside of Microsoft applications and services, we wouldn't necessarily expect third-party applications or services to understand that, since it is a custom extension. It is not defined in the RFC. So we're going to show all fields here, and so this first field is the version 3 fields. So version. So this is version 3. What does that mean? It's version 3 of the X.509 standard. So this is the latest version. Almost every certificate you encounter will be a version 3. Version 3. Next, we have a serial number. So most of us are familiar with serial numbers, like if you buy a TV or your computer, or whatever the case may be, usually have a serial number. It's like a unique identifier for that device. Well, it's the same concept here. This is a unique identifier for this certificate. So the question is, like, how unique is it? So it's definitely would be unique on a per CA basis, right? So the same CA would not issue the same serial number. Does it mean it's like globally unique, like that it's guaranteed to be, the serial number is guaranteed to never be used on any other CA in the world? No, it's not. You just could expect it to be globally unique for that CA. Is it likely that there'll be another certificate with this serial number? Probably not. Maybe there might be one or two or a few. I mean, obviously there might be some likelihood, but it is going to be pretty unique, but it's definitely going to be unique on a per CA basis. So next we have the signature algorithm. So certificates are like signed documents. So to establish a signature, you basically take some data, put it through a hashing algorithm, and then encrypt that data with a private key. And then somebody wants to validate that certificate, they run that data through the same hashing algorithm, and then they also decrypt the digital signature with the public key that's associated with it, and then they compare the hashes, and if the hashes match, then the signature has been validated. Here is the signature hash algorithm, so SHA-256. I won't go into too much detail on protocols and things like that, but SHA-256 is part of the SHA-2 family of hashing algorithms, and in certificates today you would expect to see any of these, whether it be SHA-256, SHA-384, SHA-512, you would expect to see SHA-2 uses a hashing algorithm. The previous one used was SHA-1. It's considered insecure because there can be collisions created, and you can actually manufacture some data of your choice to create the collision, and I'm not going to go into all that right now, but SHA-1 and older are considered insecure. So the idea is if your PKI is SHA-1, that should be something you're trying to move away from. This is the issuer. So we see the issuer here is in this kind of like X.500 notation here. So this is the issuer of this particular certificate. Valid from, so again, we talked about this when reviewing the general field. So, version from August 28th, 2020 to the same date in 2021. And you can even get it, you can see here it even goes down to the specific time at which it is either valid or when it becomes invalid. Next, we have the subject field. So this is one place where identity information can be stored. So essentially the main thing we look at in terms of subject field, if there's a common name or CN like there is here, is this is pretty much what we're looking for the identity to be. So any sort of applications or services would consider that www.microsoft.com the identity. So this, if you have this, so if a web server has this certificate installed, then the identity of that website is www.microsoft.com as far as the certificate is concerned. Only other thing I can really say about that is, like, for most services, especially like websites, things like that, you're going to expect the name in the certificate to match the actual DNS domain that you went to in your browser or whatever application you use to get to that service. So the public key is RSA 2048 bits or a 2K key. So this is still considered secure, but there's a recommendation for certificates that are valid past the year 2030 to be RSA 4096 or 4K keys. As far as keys, what's there to talk about? There were issues in the past where 4K keys were not able to be used by some applications, like years ago. And then as the industry saw that we're moving to 4K keys, they adopted that ability to work with 4K keys. So most applications and services that you use should work with 4K keys. You just may need to validate that in your own environment. Public key parameters, honestly I have no idea what this is. I'd have to look that up. SCT list, so this is basically works with like certificate transparency, so it's the signed certificate timestamp. We're not going to go too much into that in this article or in this discussion. We'll, in a later video when we go into more detail, we'll talk about that. Application policies. So for certificates, there's a way to determine what they're intended to be used for, like for what sort of applications. So different certificates can be used for different purposes. So in this one, it can be used for client authentication, and actually there's several different fields where this kind of purpose can be defined. So here we see client authentication and server authentication. So an example of client authentication would be like a client connecting to a VPN, a client connecting to a wireless network, that sort of thing. Server authentication is usually like a website protected by TLS. It could be like a VPN server as well. So that's kind of the purposes for this particular certificate. And so you can define certificates to have different purposes. Now, ultimately, it's up to the application to enforce these purposes, right? So for example, if you want to use if you want to enable TLS on a IIS web server, it's going to require that there be server authentication in here. You could theoretically build a web server that doesn't look at this and will just use any certificate, but for the most part, applications will honor what's specified in these fields. So this is just a way of enforcing, hey, this certificate can be used for this purpose. Certificate template information. So this is like I said, the Microsoft kind of unique extension. So this is basically the template information about the certificate template. So in Microsoft PKI, we have this idea of certificate templates, and we're not going to go into too much detail on that. It's just basically kind of like exactly what it sounds like, a template for issuing a certificate. And so here's some information about that certificate template. Authority information access. So authority information access is where so this tells me, in this particular certificate, it tells me where I can download the certificate for the issuer of this certificate. So why would I need that? So again, this is one of the purposes in this field, so I'll circle back around to that in a second. The other purpose is that it is also where the OCSP URL can be stored. So you'll see down here, there's like an OCSP URL. So OCSP is Online Certificate Status Protocol. It's a way to provide revocation information. Just at a real high level, what happens is, like if my client wanted to validate the certificate, it would send basically a request to this URL and say, hey, here's the serial number of the certificate. Is it valid or not? And the OCSP server would send me back a signed response saying, yeah, it's valid. No, it's not valid. So that's essentially what that's for. Circling back to the AIA, so what happens is I have a little example here that we can maybe use to explain that. So let's say I'm reviewing this end entity certificate. Well, it's going to have an AIA extension, and it's going to tell me where I can download this CA certificate so I can start to build the chain. In case I don't have this, like I may have this CA certificate stored locally, but if for some reason I don't, this tells me where I can go ahead and fetch that issuing CA certificate. And so if I'm validating this and I don't have the next certificate, I can go to the AIA location and retrieve that certificate. There most likely, and this kind of depends, there may be an AIA in this issuing CA certificate that tells me where I can download the Crl. You see that a lot. It's pretty, I don't know if it's definitely something that we deploy in all the PKIs we deploy, or at least the ones that I deploy. The thing is, it's kind of weird because you shouldn't have to fetch this root CA because it should be trusted. So for Windows, it would be in the Trusted Root Certification Authority store. Linux or Unix somewhere else, and that even Linux or Unix, it might even be on a per application basis. And you know, on a Cisco switch or router, there's some place where the roots are stored. But the thing is, in order for this end entity certificate to really become valid, you should trust this root CA, and in order to trust it, you usually, well, I would say you almost always would have to have possession of this certificate. So although there is an AIA defined on where to download it, it's not really super helpful because you should already have it. Okay, moving on. Subject key identifier. So this is basically a thumbprint of, I believe the technical explanation is it's a thumbprint of this certificate's public key. I think that's what it's supposed to be. Regardless, it's just basically a thumbprint that identifies this particular certificate, and I guess it's key. So it's really just a way we can identify this certificate. It's usually how it's used. Key usage. So this is kind of what the private key that's associated with the certificate can be used for. So it can be used for digital signature, key encipherment, and data encipherment. Subject alternative name. So this is another place where you can store identity information. So you see there are several identities here. So this certificate can be put on any web server that's representing any of these identities. So we see quite a few listed here. But earlier we saw that the subject had www.microsoft.com on it. Now the thing is, you have to kind of be aware of the application and what fields it uses. So TLS, for example, like a web server that's using TLS, it will ignore the subject field. So it doesn't really matter what's populated in the subject on the certificate. In fact, since there's a SAN specified, it could even be empty because the main thing that's going to be used by TLS is the SAN. So again, this certificate basically could be used to represent basically any of these identities that are listed here. CRL distribution points. So this is where I can download the CRL. So kind of going back to my little graphic here, we'll kind of look at how that sort of works. So what will happen is this root CA will publish a Crl, and this issuing CA will publish a Crl. Those Crls will be somehow, in the case of the root CA, usually manually, in the case of the issuing CA, usually automatically, published to what's called a CRL distribution point. And so and in the CRL distribution points are certificate revocation list. They include the serial number, the date of revocation, and the reason for revocation for each certificate that is revoked. And so, although I'm working my way backwards here, essentially what happens is the administrator of the CA discovers that a certificate is no longer trusted. They revoke that certificate. The next time the CA publishes its CRL, that CRL, revocation reason, or revocation date gets stamped in that CRL, if you will, and then that CRL gets published to a CRL distribution point, or CDP. So if I was validating the certificate, I would look at the CDP extension and say, oh, this is where I can download the CRL. So I go and download the CRL, and then I see if this certificate is listed there. If it's not, then it's not revoked. If it is, then it is revoked. And then next I would check the certificate for the issuer. I would go to the CRL distribution point, download the CRL, see if the serial number for the certificate is in the CRL. The root CA, we don't do the CRL checking for. We don't really do any revocation checking because the root CA is, it's like a situation where either you trust this or you don't. If you trust it, if you trust it, then you trust it. You don't, you don't. You might say, well, what if it gets compromised? Well, if it gets compromised, it's not so, you can always revoke these lower entity things, but if it really gets compromised, you just want to remove it from the trusted root certification authority store. And you can even go a step further and put it in the untrusted certificate store. So if you don't want to trust it anymore, revocation of this particular certificate is not the way to go. It's kind of making it not trusted. Now, obviously, if this was compromised, you could publish a CRL that revokes the issuing CA cert, and the issuing CA could publish a CRL that revokes its entity cert. So you could still revoke everything on down the line. So let's see, did I miss anything with CR? So the other thing with revocation is, remember, well, CRLs are just one way of checking revocation. We talked briefly earlier that there's this OCSP service, and that's another way to check revocation. For Windows clients, if OCSP is available, it'll prefer that method. And if for some reason that doesn't work, then it will try for the CRL distribution point and try to check whether it's revoked that way. Certificate policies. So this is basically for this certificate. It's just telling, this is just specifying where the CPS it can be downloaded from for this particular certificate. And this configuration allows that little button, it causes that little button to be generated to issue a statement in the certificate. Authority key identifier. So this should be the thumbprint of the issuer's public key. So this is just another way of identifying the issuer. So it's a way you can chain build. So I don't really have a chain building example here, but let's say what you would be doing, and if you wanted to chain this certificate to the issuing CA certificate, the next cert in the chain, see, this is the authority key identifier, so it's this number right here. So this number here, well, it's not really a number. This string here should be the same thing that you see in the subject key identifier of the actual CA certificate. So just for this argument, let's see if we can prove this out. Let's just remember the first two characters here, so B5. So if we look at the issuer here, we would expect the subject key identifier to start in B5 because we're not going to remember the whole string right now. So subject key identifier, see, it starts in B5. Now this next one is going to, next cert in the chain is the root, so the next cert in the chain should have this in its subject key identifier. It's in the authority key identifier on this certificate, but in the parent certificate it should be in the subject key identifier. So we'll just see this one starts with E5 because obviously you're not going to remember the whole thing. Now we're going to look at that next cert in the chain and look at this subject key identifier field, and it should be E5. And it is E5. So we can see that's one way that chains can be built. So that's the importance of the subject key identifier and authority key identifier fields. Enhanced key usage is just another way of specifying the policies for the certificate. So again, this particular certificate can be used for both client authentication and server authentication. And you'll see these OIDs here. You'll see OIDs a lot in PKI. So OIDs are just a number that like represents things. So in this particular example, this OID represents client authentication. You'll see, like, as we saw in the certificate template information, we saw there was an OID that represents this certificate template. So OID's just mapped to like something else, like a certificate template or a application policy or things like that. So it's just another way to represent those things. And then finally, so we have the thumbprint. So this is just a thumbprint of the certificate. And just another way of, and it's more just a thumbprint of the certificate file, I believe, not of the keys or anything like this, but of the whole file itself. So that's just one way to kind of compare if you need to. So that kind of concludes our discussion of certificate for today. So as we get in later on in this series, we'll go into more specific details about how to request certificates, how to revoke certificates, other things around certificates. Right now, I'm just really starting out at a high level. Again, for those that are kind of new to PKI and just trying to learn it for the first time. So we're trying to keep it real high level here. So we'll continue on. As soon as I get a chance to record another video, I'll go ahead and do that. Keep in mind, the purpose of this series, besides being a high level, is kind of be like informal, right? So it's not to spend a lot of time working on PowerPoint slides and graphics and kind of writing a script about what I'm going to say. This is just kind of me informally, teaching these concepts, and hopefully you all find that helpful. So if you do find that helpful, there's a couple things you can do. You can definitely let others know about this video. You can also go to my blog, which is listed right here, x.509.blog, and you can review my content there. You might find some other things that are useful. There's a contact page on that blog where you can contact me if you would like to, even if it's just to say, hey, I liked your video, or hey, your video sucked, or don't be too harsh, but if it's not helpful, let me know. So thank you all for your time, and I look forward to seeing you all next time.